So my name is Matt Carroll, and I'm a developer on the Flutter framework team at Google, and I'm here today to talk to you about adding Flutter to your existing Android app. Now, a couple minutes ago, I asked how many of you were familiar with Flutter and knew what it was, and not everyone raised their hand, so we're going to start with a brief overview of what Flutter is all about. So Flutter is a UI toolkit, which is not an app framework. It doesn't have many opinions about how you handle networking or database access or anything like that. It's about creating the best user experience you can for your customers. And the Flutter project is built upon 4 pillars. The first is that you should be able to build beautiful user experiences for your customers. The second is that you should be able to do it in a very productive fashion. The third is that when you deploy that user experience, it should be fast, as in 60 frames per second or better. And the project as a whole is always very open. Flutter is an open source project on GitHub. All of our issues, whether it's bugs or features, are logged on GitHub. The community is filled with a bunch of open source contributors who contribute both to the Flutter project as well as contribute to a bunch of open source libraries and plugins. So being an open project is very central to what Flutter is. Now there's a couple of these pillars that I'd like to talk about before we jump into the meat of the presentation. And the first one is that Flutter builds beautiful UIs. And I'll show you what I mean by that. Here we have a few different user interfaces that were built with Flutter. And the first one on the left, it has some nice organic shapes and organic motion, and it has a kind of a transformational UI that gives you this continuous experience. But by and large, it feels like a pretty typical UI, right? You might put that at the status quo for our industry right now. But then we move to the middle, and of course we're seeing a UI with kind of a dark theme applied to it, but also if we look at the placement, the size, the shapes of the UI elements, it kind of evokes this video game mentality, right? This video game atmosphere. And that's exactly what it was intended to do. This was a mobile game that was built for Google I/O this year to demonstrate some of Flutter's capabilities. And that third UI, here we have an app that's meant to educate you, about our solar system and about space, and every single aspect of that UI is tailored to that message and that domain. We don't have a drawer, we don't have an app bar, we don't have bottom tabs, we don't have a list of cards. We have none of those common UI elements. It is completely custom, completely branded, and completely on domain. So the point here isn't that these are the pinnacles of beauty. It's that whatever is the beautiful experience for your company, your team, and your customers, Flutter can help you do it. Every one of these user interfaces, whether we go from pretty standard to highly custom, these are all equally approachable in the Flutter API. Now the second pillar is that Flutter should be productive, but I actually say that Flutter is fast and fun to develop with. And the kind of superpower that Flutter offers to make it fun and productive, fast and fun, is what we call hot reload. And so what you're seeing on the screen here is an IDE where a developer is writing Dart code. Now we happen to be using an iOS simulator here, but the same thing is true for an Android emulator or even for a physical device connected to your machine. Every time you make a change to your Dart code and you press save, within a couple hundred milliseconds, you will see that change reflected on your simulator, your emulator, or your physical device. Now, back when I was working with IoT devices, we had a lot of setup flows, and these were a real pain to test. You have to go 5 screens into this flow to make sure it does what you want, and then you get there and the title is misspelled. So what do? You got to go back to your values file, you change the string, you rebuild, you redeploy, and you go through that whole process again. With hot reload, not only do you see changes in a matter of a couple hundred milliseconds, but you don't lose the state of your app. If you're on the 5th screen of that flow when you save the changes, you're still on the 5th screen of that flow after you save your changes. You can fix those typos, you can fix colors, alignment, shapes, right there on whatever screen you're looking at. This allows you to put a designer right next to you and work towards a sign-off in real time, and it allows you to fix bugs much more quickly. So hopefully you're all super excited about Flutter now and you want to get started. So the question is, where do you go and what do you do? Well, the simplest way to get started is actually just to create a new Flutter project in Android Studio with the Flutter plugin. That actually produces a project that includes within it an Android project and an iOS project, so you can deploy to mobile immediately the moment you create that project. But that's also not why you're here. You're here because you already have an Android app and you want to try adding Flutter to it. Don't worry, equally simple. just throw away everything you've done and start over. End of talk, right? Done. All right, I'm just kidding. Well, okay, I'm kind of kidding. I've actually been surprised at the number of teams and the size of the apps that did just that. They experimented with Flutter a little bit. They saw the value proposition, and they said, you know what, we're killing our traditional code, and we're going all in on Flutter. So there actually have been some companies to do that, but that is not at all a logistical possibility for many companies out there, and we get it. So we want to provide the best possible add-to-app experience that we can. So let's talk about adding Flutter to an existing app. And the first thing we need to deal with is the fact that we now have two projects. We have your existing Android project, and we have some kind of Flutter project. So what we need to do, oh, sorry, I forgot my warning. What you're about to see is technically not yet stable. Now, we expect it to be stable by the end of the year, and you might notice that we're at the end of November, so do with that information what you will, but technically not yet stable. So the first thing we need to do to get started here is we need to create what is called a Flutter module project, and then we need to link that Flutter module project to your existing Android project. So creating this project is very simple. Once you have the Flutter plugin installed in Android Studio, and I assume at an Android conference everybody has Android Studio, you just create a new Flutter project that's going to say, well, what kind do you want? And you're going to select from the wizard Flutter module. And when you go through that wizard and you tell it where you want your project to be created, you'll end up with a project structure that looks like this. And I only want to call out a couple details here. First, at the bottom, because we are Java developers, I want to be very clear about something. The lib directory in a Flutter project is not where jar files go. It's where all of your Dart source code goes. So don't get confused about that directory. That's actually the most important directory in the whole project. But then up at the top is the interesting part. We have this .android directory, and that is actually a full-fledged Android Gradle project. And in that project is a Gradle module, which means theoretically we should be able to not only build it as an Android asset, but also link to it as well, which is exactly the two options that we have. There are two ways to bring this Flutter project into your existing project. One is to actually build the Flutter module as an Android archive. And at that point, you can consume it like any other Android archive. Your app doesn't care that it's a quote-unquote Flutter project. Now, this comes with one upside and one downside. The upside is that for large teams where you have people that don't want to touch the Flutter stuff, they can bring in the Android archive. They don't need Flutter set up on their system at all. They can consume it. They can build your app. They're none the wiser. The downside is that every time that you want to see changes from your Flutter module in your main app, you have to rebuild the Android archive, and you have to rebuild your main project, just like any other Android archive. But that then takes us to the second option, which is that because there's that Gradle module in your Flutter module project, you can actually link your existing Android project directly to it. And every time you build your main app, it will automatically build your Flutter module. You will always be up to date. You don't have to worry about manually doing that migration. In that case, though, everyone that builds your main app needs to have Flutter set up on their system. Now, this is all handled pretty much with Gradle, so you can kind of script this. You can do one thing on your CI system. You can do something different on your local machine. It's in your control, but you have both of these options. And I'll show you how to set these up. So let's start with building an Android archive. Building the Android archive is really easy. You open up the Flutter module project in Android Studio, and if you open up your build menu, you're going to see a Flutter submenu, and then you're going to see an option that says Build AAR. This will compile your Flutter module into an Android archive and dump it into a subdirectory of the build folder in this project. And so then all we have to do is consume that Android archive in our existing Android app. And this is how you do that. So open up the build.gradle for your existing Android app, and the first thing you're going to do is add a couple of Maven repositories. Now, the first one here is actually local. You just need to point this to your Flutter module on your local machine. That subdirectory starting with build, host, outputs, all that you can copy that from this slide. It's exactly that structure. But the path to that module, you need to set that up for your local machine. The second repository points to Flutter's centralized hosted Maven repository. There are a few artifacts that we need to pull down to actually get the compilation to work correctly, so you need to list that as well. But then in terms of dependencies, you can list this AAR the way you would pretty much any other. You can set up a dependency for debug build type specifically and release build type specifically, and then you just need to use the package name that you used when setting up your Flutter module, and you specify either Flutter underscore debug version 1 or Flutter underscore release version 1. Versioning doesn't really happen, so it's always 1.0. But at this point, when you compile your app now includes the compiled version of that Flutter module. Your projects are linked up. That brings us to the second option, which is to actually link the projects directly. This is the one, it requires Flutter to be set up on your developers' machines, but it allows you to automatically build your Flutter module every time you deploy your main app. So to do that, you start by opening up settings.gradle in your existing project structure, and you pretty much just copy this code that you see here. Again, the only adjustment you need to make is to point to your local Flutter module. But once you sync this change, once you save this and do a Gradle sync, suddenly in your project structure you will see a module called Flutter, which then leaves just one more step. We need to tell Gradle that our existing Android app depends on that module. So an implementation dependency on the project called Flutter. Now again, I'm sure many of you have seen this same syntax before. This is how you depend on any Gradle module that your project is aware of. And so at this point, your Android project is linked to a Flutter module. But then it kind of begs the question, now what? What do you actually do with that module that you've linked? Well, that's not good. All right. So the question is, how do we actually use Flutter's Android APIs? We're going to talk about how to display Flutter in a full screen context. We're going to talk about how to display Flutter as a part of your UI. And we're even going to talk about or touch on very briefly the idea of Flutter as an individual view. So in Android, what does it mean to show something full screen? It means we have an activity. And how do we typically launch an activity in Android? We respond to something like a button, click, we say start activity, and we pass an intent to the new activity. So in Flutter, or with Flutter, we respond to something like a button click, we say start activity, and then we pass an intent. And in the simplest case, you can simply invoke Flutter activity.create default intent. And that will create, again, this default configuration of a Flutter activity. And when you start that activity, you will be presented with a full screen display of whatever Flutter UI you've defined in your Flutter module project. Now, when you use this for an add to app perspective, you're likely to have use cases where you're using Flutter on the periphery of your system. So you might want to launch Flutter over here for a user profile page, but you want to launch Flutter over here for some kind of messenger. It's a different experience every time. And for that purpose, we offer a little bit of configuration here that you can also, by using the with new engine builder, you can specify a specific initial route. So you can say this activity should actually jump immediately to this part of our experience, this part of our app. We'll come back to the with new engine part later, but the initial route here is what allows you to configure that. So if we launch this Flutter activity, the first thing we're going to immediately see is the profile for user 123. Now, how about partial UI? Well, generally speaking, we're now in the world of single activity apps, which is great, but it means that most of our content takes the form of fragments. We might have, let's say, bottom tabs built with Android, and we have some Android content on the first screen, but then we go to the second tab, and now we want some Flutter content. So the question is, how can we use Flutter as a fragment? How do we use any fragment? We get the fragment manager, we begin a transaction, we add a fragment, we commit the transaction, and then we're done. So with Flutter linked, we can get the fragment manager, begin a transaction, add a Flutter fragment, and then commit it, and we now have a Flutter experience displayed within a fragment. Now again, here we offer this create default factory method. This time we're actually getting a fragment, not an intent, but it uses default configuration. We also offer the same kind of builder. So that fragment can now display a specific route within your Flutter app immediately. Okay? And now let's touch just briefly on this idea of using Flutter at the view level. And really I'm just here to warn you against doing that at this point. So there is a Flutter view, and actually Flutter view is used within Flutter activity and Flutter fragment. It's a very important part of the system. However, we do a lot of plumbing on your behalf when it comes to Android lifecycle methods, activity callbacks, and things like that. We send that information to Flutter at the right time in the right way, and if you choose to use Flutter view yourself right now, you're going to have to do that on your own. You're welcome to copy our code. I'm just letting you know it's a little tricky and it's a bit of overhead. So if you do have a use case, by the way, that needs Flutter as a view, please log a ticket with us because we're always collecting these use cases. We want to know why you need it, and if we can understand that, then we can offer it to you in a form that will work very well for your use case. Now there's one thing I've kind of skipped over here. If you actually launch a Flutter activity the way that I've described, let's say you're starting with an Android screen, for a brief moment when you launch that Flutter activity, you're going to see nothing at all. It might be white, it might be black, depending on your theme, but you're going to see nothing, and then after a brief moment, you're going to see your Flutter UI. And this is because Flutter actually has a non-trivial initialization process. Flutter needs to set up Dart execution. It needs to set up a number of dedicated threads. It needs to do the initial sizing and rendering and pumping of a frame in Flutter, and that's what that difference in time is. But we do have a way for you to minimize that to the point of being almost undiscernible. Behind every Flutter activity, Flutter fragment, Flutter view, there's something called a Flutter engine, and that is the object responsible for doing all of the initialization. We have a way for you to initialize one of those before you need it. We call it warming up the Flutter engine. And if you do that, you will get the minimum possible visual discrepancy between the Android experience and the Flutter experience. And again, on modern devices, you're not even going to notice it. So here's how you actually do that. Somewhere in your code, and arbitrarily, let's say you choose to do this in your application class because that works fine, but depending on how your app is structured, you might want to do this somewhere else. But somewhere, we just need to create an instance of this Flutter engine. We'll pass it a context to instantiate it. The instantiation process does not do any meaningful work, but we need an instance of it. It's the next part that's really important here, which is we need to tell it to start executing Dart code. That's the initialization that takes a little bit of time. Now, this is not a blocking call. You can call this on your main thread. It's going to go off and do the work independently. But calling this early is what's going to minimize that initialization time. But even once we've initialized this Flutter engine, we still need to do something with it. How do we get this into an activity or a fragment? Well, we offer something called the Flutter engine cache, which is a static singleton. So if you grab that instance and you simply put your Flutter engine into that static cache, and you can give it any ID that you want. The Flutter activity and Flutter fragment actually know about this cache. So by putting it in there, we can instruct the activity or fragment to use that same engine. And here's how we do that. With Flutter activity, remember that .withNewEngine part? Guess what? It meant create a Flutter activity with a new Flutter engine. So the alternative is, let's create a Flutter activity with a cached engine, and we give the ID of the cached engine that we want it to use. Now when we launch this activity, we will see almost no visual discrepancy or lag between the Android activity and the Flutter activity. And we can do the exact same thing with Flutter fragment. So Flutter fragment also has a with cached engine. You pass in the ID. Now your Flutter fragment is using your pre-warmed engine. And so with that, you should be pretty much good to go. And so we looked at how to launch a full screen Flutter experience, Flutter as a fragment. I warned you about using Flutter as a view, and now you know that they're all backed by this Flutter engine thing, which you can put in a static cache. But I don't just want you to know how to launch Flutter. I mean, that's hopefully you have fun getting started with that, and that is all you really need to know to go to production. But given that we're all Android developers, I'd like for you to also know a little bit about how Flutter actually works on Android, how it actually comes into the platform. So let's start by talking about rendering pixels. And let's look at some examples of how other systems render pixels on a mobile device. Let's talk about video, for example. You know, whether a video file exists on your device locally or you're streaming data from the server, there's some kind of media encoded data that eventually comes to the device and hits a decoder. That decoder then paints a texture in the GPU, and that texture is then copied to your screen. And that's essentially done on a per frame basis, and that's how video pixels get to the screen. Let's talk about video games. The video game, you might have something like a scene graph, some kind of complex representation of your game state. That whole system is reduced to a number of graphics primitives, which are sent to something like OpenGL or Vulkan or Metal, which then in turn paint a texture in the GPU, which is then copied to the screen of your device. And that's how you actually experience kind of a video game UI on a mobile device. So now let's talk about Flutter. In Flutter, you're going to spend most or all of your time working with the Flutter framework, which is a bunch of Dart code. You write Dart code that creates the UI, but at runtime, that Dart code creates a number of primitives which are sent to the Flutter engine, which is primarily written in C++. That Flutter engine takes those graphics primitives and paints a texture in the GPU, which we then copy to the screen. So fundamentally, that is how Flutter renders pixels. Now the question still remains, okay, like literally in terms of Android code, what does that mean? So I want to walk you through those pieces as well. Let's say that we have this hypothetical Android device here, and we'll break it apart, and we know that at the top level is Flutter activity. Within Flutter activity, we have two pieces. We have this invisible Flutter view, which is responsible for intercepting all touch events, talking to the keyboard, dealing with accessibility, but it renders nothing. And then within it, or beneath it, depending on how you want to look at it, we have either a Flutter surface view or a Flutter texture view, which simply displays a full screen texture. And that's where those pixels actually get displayed on the screen. And I want to be really clear what I mean about how these work. Flutter can look magical, but I want to be clear about how not magical it is. So how many of you, by the way, have ever overridden on touch event or on generic motion event? About 10, 15% of you. So most of you probably just work with on-click listeners and gesture listeners and things like that. You go low enough down, and there's just a stream of raw events coming through that Android is interpreting on your behalf, and they're saying that's a tap, that's a long press, that's a gesture. Well, what Flutter View does is we override those fundamental touch event methods. And instead of having the Android framework interpret what those mean, we send them over to Flutter, and we have Dart code that runs that now identifies tapping, long pressing, and gestures and things like that. And that frees up Flutter to give you some really powerful gesture recognizers. So I'd recommend you go play with the gesture system as early as you can. You can do a lot of fun stuff pretty quickly with Flutter. But it starts here, which is give us every raw event from the framework, send it on over to Flutter. We do the same thing with keyboard input. So on key up and on key down, those again are simple events. We just forward that over to Flutter. Flutter decides what to do with it. But also, if you want to have some kind of custom view that knows how to talk to the keyboard, you need to offer a custom input connection. So we also override on create input connection. We offer a Flutter-based input connection, and that's how Flutter actually works with the keyboard. Again, if you've created a highly custom view, you may have done the exact same thing. And then here's mouse support, which I didn't even know was there for a long time, but apparently it is. And accessibility. Accessibility is critical in Flutter. This is a constant first-party citizen within the Flutter ecosystem on all platforms. So on Android, if you create, again, a fully custom view, if you're rendering your own UI, you need to tell Android what is inside of that UI. And you do that by providing a custom accessibility node provider, which of course we do for Flutter. So we have this big screen of pixels, and within that screen there are titles and buttons and images. And this node provider is what tells Android where those titles and buttons and images really are. So we actually give the geometry of each one of those things as well as the semantic meaning. And that's all accomplished here by providing a custom accessibility node provider. Now how about Flutter Surface View and Flutter Texture View? I'll just kind of rattle these off. If you've ever extended one of these, you know it just comes down to implementing a few callbacks. So when we extend Surface View, we're going to be notified by Android when a texture is created. And so we just tell the Flutter engine, hey, this surface is available, go do whatever you want. And then Android says, hey, it's changed in some way, like maybe the size changed. Okay, Flutter engine, your texture has changed size. And then finally, Android says, we've gotten rid of your texture, so clean up your resources. Well, we forward that information right over to the Flutter engine. It cleans up all the references. And it's almost the exact same thing for Flutter Texture View. This is just kind of a newer API, one extra callback. So again, your surface is available. Your surface has changed size. This one also tells us when a new frame has rendered, which actually doesn't really matter for Flutter because we are rendering the frames, but it's there in case you want it. And then at the end, it's destroyed. Clean yourself up. So those are actually the technical details of how Flutter works on Android. It's how Flutter renders pixels and deals with user input. I'll give you a rapid recap of all that stuff. So again, we said Flutter needs to render pixels. It renders pixels to a texture. Those textures get to the screen either via Flutter Surface View or Flutter Texture View, but that's not an interactive surface. So we wrap it with a Flutter view, which invisibly adds touch input, accessibility, interaction, keyboard input, etc. To make that useful for all of you, we provide it either as a Flutter activity or a Flutter fragment. Now, Flutter activity, Flutter fragment, Flutter View, Flutter Engine, all of these Java classes are what we refer to as Flutter's Android embedding. So if you ever hear that term, Flutter's Android embedding is talking about all those classes we mentioned here today. Now, every Flutter module project that you create has access to all of those classes. It's part of what you build in a Flutter module, which means that when you link your existing project to a Flutter module, you gain access to Flutter activity, Flutter fragment, Flutter Engine, and all the rest of it. And so that is how Flutter actually works on Android, and that's how you add Flutter to your existing Android app. So thank you very much for being here, and I'd be happy to take any questions.